Hey, it's that time of the day. Let's do some math here. Hopefully, I can get that fly.
Okay, 11.1. Radical expressions and rational exponents. So radical expressions means, the expressions that we write are going to use that radical symbol. Other examples are like the third root. This is the second root, or the square root. So we've seen numbers like this, like the square root of 4 is 2. The cube root, or the third root of 27 is 3, because 3 times 3 times 3 is 27, right? And 2 times 2 is 4. So if, we want to figure something out, like what's the fifth root of 64, right? So is there a number you multiply by itself 5 times to get 64? So I just want to think about this for just a second. 64, we know, is 8 times 8, right? And 8 is 4 times 2. And 4 is 2 times 2. So 64 is 2 times 2 times 2 times 2 times 2 times 2. Right, there's 1, 2, 3, 4, 5, 6 of them. Well, this is the fifth root. Okay, so if we're simplifying these, and I'll go back to this, I'm just trying to introduce a concept to you. The fifth root of 64, if you reduce 64 to its prime factorization, in order for anything to come out of a root, you've got to have this number of them. Let me go back to this one, right? Because we've done this before. The second root of 4, which is 2 times 2. If we want to take and simplify this second root, this square root, we need 2, that number, of the same thing multiplied together in order for it to simplify. So since we have 2 2's multiplied, this simplifies into 2. And notice once it's simple, it does not have the radical symbol anymore. Okay, let's look at this one. The third root of 27. Okay, 27, if we find the prime factorization of 27, we know it's 9 times 3, and 9 is 3 times 3. So we can write the third root of 27, we can write that as the third root of 3 times 3 times 3. And in order to simplify this, we need that many of the same thing multiplied together. And there happens to be this many 3's. So once you have 3 3's, 1 comes out. And the answer is 3, right? And we already knew that. So now let's look at the 64, which we know is 2. 2 times 2 times 2 times 2 times 2 times 2. There's 6 2's multiplied together. In order to simplify this radical, we need 1, 2, 3, 4, 5 of the same thing multiplied together in order for 1 to come out. So 2 to the 5th power and the 5th root of that times the 5th root of just this last 2 there. Okay, all I did was change this 2 times 2 times 2 times 2 times 2 to 2 to the 5th. Now when the power equals the root, they cancel. And you just get 2. And this thing, since there's only 1 in there, not 5, it has to remain as a root. 2 times the square root of 2 times the 5th root of 2. That is the 5th root of 64 simplified. Now, let's go back to something that's easier. You can rewrite any radical so that it has a rational power. And a rational just means a fraction. Now, when you have a rational power, rational means fraction, the top of the fraction is actually the power. And the bottom of the fraction is the root. Okay? The top is the power, the bottom is the root. Now, let's look at this. This is a, and it's the second root because it's a square root. And we can write this radical as a rational exponent, meaning a fractional exponent, where the top is the power and the bottom is the root. Now, what's the power on this? I don't even see a power there. So when there's no power, it's an invisible 1. What's the root? When there's no number right there, it's always 2. So you can write the square root of a as a to the 1 over 2. The square root of a is a to the 1 over 2. In this case, if we're trying to figure out what m's value is, the square root of a equals a to what power? In this case, m equals 1/2. Okay? That's just a quick introduction. Actually, today, I think I'm just going to give you notes and not an assignment. Okay. So here's another problem just like it. Okay, that 3 in the v part of a radical symbol is the root. Okay, so this is a to some power. Remember, when you're trying to find out the fractional power, the top is the power, and I don't see a power here at all. So the power is not 0, the power is a 1, right? And the root is the number that's right there. And when there is a number there, then that's the number that goes in the denominator. So this is a to the power of 1/3. And that equals a to the m. So m, in this case, is 1/3. Okay, so here are some examples. It's a little more challenging. This says, translate the radical expression into expressions with rational exponents. And vice versa. So if you have a rational or a fractional exponent, we're going to change it to radical. And if you have a radical expression, we're going to change it to a fractional exponent. Okay? So remember, the top is the power, and the bottom is the root. So we can take this number, negative 125, and write it as a radical. The root is 3, so it goes here. The power is 4, so it can go here, or it could go on this number, negative 125. And then simplify the numerical expression. Okay?
I'm going to take off sweatshirt.
So let's see if we can figure this out. What do you multiply by itself 3 times?
I put it on when I woke up this morning. Yeah, but I had blue shorts on first, and you had the same shorts on
You can hear my daughters. They're having a lively discussion. Hopefully it's not too loud to disrupt your thinking. Okay. Now, if we want to figure that out, there's lots of ways to do it. But we can take 125. Can I do this work right here, 125? And find the prime factorization of it. 125 is, if you think about money, it's 5 quarters. 5 times 25. 25 is 5 times 5. So 125 is 5 times 5 times 5. But negative 125 is negative 5 times negative 5 times negative 5. Okay? And all of that is to the 4th power. So we can rewrite this, and you don't have to do it like this every time. We're really, when you're taking the 3rd root, you're just looking for the number you multiply by itself 3 times to get negative 125. And of course, you can see that that's negative 5. But I could rewrite this. Negative 5 to the 3rd power, and then the 3rd root of that. And when the power and the root are the same, they cancel each other. So this is really negative 5 to the 4th power. Okay. And that should not be too hard to find. When you take anything to a power, make sure you put it in parentheses. Because if I don't put it in parentheses, I try negative 5 to the 4th power. Look, the answer says negative 625, and that is not true. If I took negative 5 times negative 5 times negative 5 times negative 5, you get positive 625. The problem is when you have a negative sign and a power, the order of operations does the power first and then puts the negative sign second. It's kind of like a multiplier by negative 1. Anyway, 625 is the answer for A. Once you see, okay, let's do B now. All we have to do is rewrite this rational exponent as a radical. So x is going to be inside the radical. You just have to put the power in the right spot and the root in the right spot. Okay, the power is 11, the root is 8, and that's it. It really isn't so bad. For C, we are going to rewrite this as 6 to a power, so fractional power. The power, the 4, goes on the top in power position, and the 5 goes on the bottom like roots of a tree. It's the roots of the radical. So this expression can be rewritten like that. And D, I wish this were gone. I'm going to get rid of it quickly. D, we're going to rewrite x and have a fractional power. The top is the power. The bottom is the root. Okay? Hopefully you guys are good with that.